Hello, my name is George Aguilar. Today's video is going to be discussing the startup procedure on a Cla-Val model 50-01 pressure relief valve. The discussion today is intended to provide a basic overview of a typical commissioning procedure. Now, each system is different with its own hydraulic characteristics, and that should be taken into consideration when planning a proper startup. Let's get started. So for this discussion, we're going to assume that this is a newly installed valve or a valve that has been recently serviced or rebuilt and is being placed back into service. Now, a pressure relief valve is intended to maintain a maximum upstream pressure. So our CRL is looking at upstream pressure. As upstream pressure starts to rise, the CRL is going to open, allow water off the cover, and the main valve is going to open. At this time, the valve is going to be modulating as needed to prevent the rise of any excess inlet pressure. The valve is intended to open quickly and close slowly to prevent any further pressure surges. Now, a model 50-01 can either be used as a pressure relief valve, a pressure sustaining valve, or a back pressure valve. If the valve is located in a pipeline, there should be isolation valves located on both the inlet and the outlet of the valve. And if your relief valve is going to be discharging into atmosphere, then there may only be an inlet isolation valve needed. But for this discussion, we're going to assume that all the isolation valves are closed prior to the startup. So inlets closed, outlets closed. Since the valve is designed to regulate inlet pressure, for startup and maintenance it's important to have a pressure gauge mounted at or near the valve inlet. So gauges can be either installed on the pilot system of the valve. So here on the CRL you have an inlet port and you have an outlet port. You can install an inlet gauge here, or you can install a gauge on the inlet body plug of the main valve. So you have an available plug here as well. It's important to have some type of gauge where you can get a reading of what your pressure is in the system at the time of startup. So during startup, a large volume of water may be discharged downstream, and proper planning must be done to accommodate this flow. Pilot adjustment changes, when they're made, they must be done slowly to prevent any type of inlet pressure surges. So it's important to know what your setting is of your CRL. It's important to know what your CRL spring range is. You can find this out by either a sticker on the power unit body of the CRL, or there might be a brass tag installed letting you know what that current spring range is in the CRL. Or once you know what that spring range is, then you can determine what your PSI per turn rate is on the adjustment screw. So first, we're going to make sure that all the pilot isolation ball valves are open. If your valve is equipped, there's going to be ball valves located on the inlet, on the cover, and on the outlet of the main valve. The pilot isolation ball valves come standard on valves 4-inch and above, 4-inch and larger, and they're an optional feature on valves 3-inch and below. So you have an inlet, a cover, and a downstream ball valve. So the first thing that we're going to do is we're going to loosen the jam nut on our X42 into. This is our combination Y strainer and closing speed control. So we want to make sure that we get this set. This is also our restriction fitting. So we're going to loosen this jam nut here, and we're going to turn this adjustment screw clockwise until it seats. Once you've got it all the way down and it is seated, we're going to back that stem out to a quarter to a half turn out. So here I'm going to go a half turn. We're going to tighten that jam nut. And this is going to be our initial closing speed setting. We'll lock this down, jam nut down. Now we're going to remove the cap of the CRL. Removing this cap is going to get us access to the adjustment screw. Once you've gotten to this position, we're going to loosen up the jam nut on the CRL. And we're going to go clockwise to turn to make sure that this CRL is seated. Again, clockwise is going to increase the spring tension on the CRL. Because the CRL is a normally closed pilot, by turning in on this adjustment screw, it's going to increase the pilot setting to the upper spring range limits. By closing the CRL, this will put the main valve under the control of the CRL. So if we follow the water here from the inlet of the valve, if our CRL is in the closed position and we follow the water here, the water is going to have nowhere to go because the CRL is closed. It's going to back up, water pressure is going to back up onto the cover of the main valve, and it's going to close that main valve. So your valve may be equipped with either a CRL or a newly designed CRL 60. Both pilots operate identically. If you have any questions, please refer to our CRL 60 maintenance video for specific rebuild instructions. Now, if there's an isolation valve located downstream of the 5001, we want to slowly open up that isolation valve. After you slowly open that up, next we're going to partially open up our inlet isolation valve. By doing that, we're going to allow some of that inlet pressure into the valve. By getting that pressure to the valve, again, water is going to back up onto the cover of the valve, and the 5001 should close slowly. During this time, the valve may discharge a little bit of water as the valve cover begins to pressurize and close, so just be aware of that. Once the valve is closed, we want to make sure that we vent all the air from the main valve and the pilot system. So if your valve is equipped with an X101 valve position indicator, like we have installed right here, we can loosen the bleed valve at the top of the indicator assembly and release all the air until we have a steady stream of water. So we'll loosen up this bleed valve here just a little bit, again, until you get a steady stream of water coming off here. Once you've had that steady stream, you no longer see any air bubbles. You see a steady flow of water through the sight tube here. We'll tighten up that bleed valve, and we're on to the next step. If there's not an X101 mounted on your valve, there will be a body plug here similar to what we have installed on this valve. On the cover here. Again, if you don't have this X101, just loosen up that bleed valve. That bleed valve will be installed here. Loosen that bleed valve a little bit and tighten that back up. Next, we're going to carefully loosen the tubing at the highest point. So in this case here, on this valve that we're using for our demonstration, the highest point is going to be at this point. So we're going to loosen up this fitting just a little bit, again, until you have a steady stream of water. Once you have that steady stream, we'll retighten. Once all the air is vented, once you've done that, now we can fully open up our inlet isolation valve. So now inlet and downstream of our 5001, both of those gate valves or isolation valves are fully open. So now with the main valve now in the closed position and all the air is vented, it's time to decrease the CRL setting until the valve begins to open. So what we're going to do is we're going to slowly back out on the adjustment screw until you start to hear flow make its way through the pilot system, or when you start to see the stem rise on our position indicator, either or. So we'll slowly start backing out. All right, when you start to hear flow through our pilot system, you're going to look at your installed gauge. You want to look at your upstream pressure, because when your CRL starts to open, it's opening at the current setting of our upstream pressure. So now you know what pressure the valve is currently set at to open, which is your current system pressure. If that current pressure is below the required relief setting, then based on the spring range of the CRL pilot and the known PSI turn of the adjustment screw, you're going to turn clockwise to increase the pressure setting to the proper required setting. So if I start to back out on the CRL and you start to hear that flow make its way through the pilot system, let's say your PSI per turn is 9 PSI. We're going to increase this half, a full turn. That's going to give me 9 PSI over what my current setting system pressure is. So once you've determined what your proper setting is, we'll tighten the jam nut. Tighten that jam nut. We're going to return the CRL cap. And that is the basic startup procedure for a Cla-Val model 50-01 pressure relief valve. That concludes the basic startup procedure for a Cla-Val model 50-01 pressure relief valve. For additional videos or literature pertaining to the model 50-01 or our CRL pilots, please visit our website. Thanks for watching.